Okay, welcome back. So ngayon, or last meeting, we started with our lessons sa Physics 173. Okay, sa electronics physics. And ang diniscuss natin, okay, o yung topic natin ay circuits with DC sources. So, yung mga na-discuss natin na types ng circuits before, kung napansin nyo ay a little bit different, okay, kumpara sa mga circuits na na-discuss sa Physics 102. At itong mga topics na to or yung circuits na ito ay yung voltage divider circuit at yung Wheatstone bridge. And discuss natin itong mga circuits na to kasi these are fundamental circuits. These are basic circuits na makikita nyo sa mga advanced na circuits na pag-aaralan din natin later. Okay, but in general, in any advanced circuits, yung voltage divider circuit is really fundamental. You'll always see this in any type of circuits. And in fact, even itong Wheatstone bridge, we already discussed na this can be broken down into two voltage divider circuits. Okay. Okay, so just to recap, okay, a voltage divider circuit is a circuit that divides the input voltage. Okay, and the way to do that is to use these two resistors. Okay, and then to take the output across one of the resistors, and that output will be a fraction of the input nung DC yung full na DC na circuit. Okay, and sa Wheatstone bridge naman, okay, so this is a type of circuit where you have these four resistors, pero you take the output from points A and B, okay, across A and B, and to do that, first you need to take the output across or output at point B with respect to the reference and output at point A with respect to the reference, and then you take the difference, okay, to take the output between VB and VA, okay. So yan yung Wheatstone bridge. Okay, and kahapon, or last time, ang diniscuss natin ay kung paano i-derive yung voltage output sa Wheatstone bridge. And nakita natin na yung voltage output is given by this equation. Sandali. Hindi nag-respond yung pen na. Okay. Dali, i-reconnect ko lang yung pen ko. Dali lang. Ano, may battery pa. Yun. Okay, it's connected. I hope meron pang battery. Okay. Nice. Charge. Okay, so ito yung circuit or sorry, equation that describes the output dun sa Wheatstone. Output ng Wheatstone bridge. Okay. So, discuss din natin last time that when the output is zero, okay, when the voltage output is zero, then we say that the bridge is balanced. Okay? Yung bridge ay balanced. Okay? And pag-balance yung bridge, then we also have this, or we also get this condition, okay, for the Wheatstone bridge. Okay, so yan yung diniscuss natin last time. Let's continue with the discussion. Okay, so may example din tayong diniscuss last time. Now, the Wheatstone bridge, you use it for many applications, and when you use it, the bridge doesn't have to be balanced. In fact, you can use it even for applications that don't require balancing the circuit. Okay, tawag dito, yung isang application nito ay when you use the Wheatstone bridge with what's called a transducer. Okay, so ano ba ang transducer? So ang transducer is any electronic device, okay, that converts an analog signal to an electrical signal. Okay. So sige, sulat natin yun. So a transducer is an electronic device that converts an analog signal to an electronic signal. Okay. So for example, ano bang examples ng mga analog na signal? So ang mga examples dyan ay pressure, okay, temperature. Okay, so yun yung mga na-measure natin na na tawag dito, environmental parameters, di ba? Humidity, for example. Okay, and what the transducer does is to convert itong pressure na ito into an electronic signal na pwedeng basahin ng inyong circuit, okay, na inyong electrical circuit. Okay, so I believe na isa sa mga magiging experiments ninyo sa lab is how to calibrate or how to make an electronic thermometer. Okay, and the way to do that is to use the Wheatstone bridge. And the transducer that you're going to use is a temperature sensor, or what's called a thermistor. So in the lab, gagamit kayo ng thermistor. Okay, thermistor. Okay, anong thermistor? Well, a thermistor, I don't know kung ma-extract nyo, but this came from two words, thermal at saka resistor. So a thermistor, okay, the way a thermistor works is that when it measures temperature, the resistance of the thermistor changes. Okay, and that's why yung Wheatstone bridge is a perfect circuit to use a thermistor for. Okay, so kasi when the resistance of this transducer changes, okay, so nagbabago yung resistance niya dito, then the output also changes. Okay, and you can measure, okay, you can actually make a or calibrate a thermometer based on the output of this circuit. Okay, so ang typical na ginagawa or ang gagawin niyo rin most probably sa lab is you set it, okay, at room temperature. Okay, ang una niyong gagawin is you design a a Wheatstone bridge such that the bridge is balanced. So ang gagawin niyo is i-measure niyo yung resistance ng transducer. Okay, so yun yung resistance corresponding to room temperature. Okay, and now after nyo ma-measure yung resistance ng transducer at room temperature, so i-design nyo na yung Wheatstone bridge nyo. So alamin nyo kung ano yung R3, R4, tsaka R2 such that the bridge will be balanced. Okay, then to calibrate yung yung thermometer nyo, ibababad nyo ngayon itong thermistor ninyo sa ice bath. So, kukuha kayo ng tubig, lalagay nyo ng yellow and everything. Okay, then it will give you an output voltage. Okay, so, sige, if we graph that, okay, so ganito yung mangyayari. So room temperature, sabihin natin nasa Baguio kayo. So room temperature is 20 degrees Celsius. And the bridge is balanced. So that corresponds to 0 voltage. Okay, so yan yung V equals 0. Okay. Then you measure yung you lower the temperature, okay, by putting the thermistor in an ice bath. So sabihin natin 0 degrees Celsius. Okay, what you find out is that yung voltage, okay, output, okay, VAB has some value at 0 degrees Celsius. Okay? And makikita nyo na yung value niya is somewhere here. Okay? Tapos, next na gagawin nyo, okay, or actually, pwede nyo na sabihin na nakalibrate nyo na. Okay, so what you're going to do now is to draw a straight line. Of course, ang assumption dito is that yung response, okay, nung thermistor ninyo is linear. So the assumption is that the electrical response of the thermistor is linear. Okay? So yun yung unang assumption. Okay. Ang second na assumption is that it has a negative thermal coefficient. Okay? Kaya yung slope dito is negative. Okay? Pag sinabing negative yung thermal coefficient niya, ibig sabihin, pag nag-increase yung kanyang, as the resistance increases, then the voltage decreases. Okay? So yun yung nagiging response niya. Okay? But, matutunan nyo rin sa lab na there's for every electrical device, merong data sheet. So you can actually pull out, okay, from the internet yung data sheet para sa mga electrical devices, para sa thermistor na gagamitin ninyo. So yung mga thermistors na yan, meron yan label. Okay, so titignan nyo lang yung label, hanapin nyo sa internet yung label, and then you can pull out the data sheet. So dun pa lang malalaman nyo na yung response, kung linear siya or non-linear, kung meron siya negative thermal coefficient. Okay. So, yun yung ginagawa diyan. Okay, yun yung nangyayari diyan. So that's how you calibrate this electronic thermometer, okay, shall we say. Okay, so if you want to know kung ano yung tawag dito, if you want to know kung ano yung halimbawa gusto niyo gamitin to sa isang tao na may lagnat, di ba? Okay, tapos ilagay niyo sa amba, sa leeg, sa kilikili, di ba? So, pag ginawa niyo yan, ang gagawin ng Wheatstone bridge ninyo is that it will give you an output. Okay, it will give you an output which may be negative, di ba? So, negative V something, okay? And it may correspond to, sabihin nating 37 degrees Celsius. Okay? So, doon natin malalaman oops, ito pala yung 37. So, doon natin alam na, or doon natin, ganyan ngayon nag-work ang inyong electronic na thermometer. Okay, now, of course, there some cases na positive yung thermal coefficient like this one. Okay, so dito sa example na ito. Okay, you have this linear na calibration curve. Okay, so yun yung dash line. Okay, but when you do your measurements, okay, it may not be that linear. Okay, so it could be na ito yung solid line yung fina-follow niya. But you won't be able to see kung gaano siya ka-non-linear if you don't make very precise measurements. Okay? So ganun. Now, of course, medyo mahirap na gawin yan kasi anong gagawin nyo para increase yung temperature like to exactly 26 degrees, to exactly 27 degrees, di ba? So hindi siya madaling gawin sa isang experiment. Okay? So anyway, yan yung isang application ng transducer when the output voltage is nonlinear. Ang isang application niya is the use of transducers in an electrical circuit. Okay? So any questions? Okay. Now, ang next topic natin is not an electrical circuit, but instead, it's a way to understand how electrical circuit works. Okay, at ang tawag dito sa topic na ito or sa concept na ito ay Thevenin's theorem. So ang sinasabi ng Thevenin's theorem is that lahat ng circuit ay merong Thevenin equivalent. Okay? At yung Thevenin equivalent circuit can be constructed in this way. Okay? Meron kang Thevenin voltage at meron kang Thevenin resistance. Okay? Lahat ng electrical circuits. So, ibig sabihin, for example, okay, last meeting pinag-uusapan natin yung mga mobile devices ninyo. And alam naman natin na pag binuksan niyo yung mobile devices, yung punong-puno yan ng electrical components. Meron yung IC, may mga sensors yan, di ba? And bawat isa sa mga components na yun ay meron mga resistance. But ultimately, there is an effective resistance, okay, na ma-measure nyo dun sa output, okay, dun sa terminal kung saan kayo nag-charge, okay? If you can measure that resistance at that terminal, then that resistance is the Thevenin resistance. Okay. Ano yung Thevenin na voltage? It's something that you can also measure, but we'll get to that when we actually define kung ano yung Thevenin na voltage. Okay. So well, the Thevenin voltage in the case of in the case of yung mga mobile devices is yung voltage na kailangan niya para i-charge yung device niyo. Okay? Kung hindi mobile device yung gagamitin natin na example, for example, halimbawa ano ba, ventilador, halimbawa. Okay, you can get ang tawag dito, you can get a multimeter. Okay, kuha kayo ng multimeter, iset nyo sa resistance. Okay, tapos ilagay nyo lang yung terminals dun sa plug. Okay, tapos i-measure nyo yung resistance. So yung resistance na yun, it's the effective resistance ng buong electric fan. Okay, and that's your Thevenin resistance. Okay, and then the Thevenin voltage is the voltage that's required to power, okay, to give power to the electric fan, which is of course 220 volts. Okay. Okay, so there's a way, okay, theoretically to solve for the Thevenin resistance and the Thevenin voltage. Okay, so and to do that, i-define ngayon natin kung ano yung Thevenin voltage at resistance. So the Thevenin voltage, the Thevenin equivalent voltage is the open circuit no load voltage between two specified output terminals in a circuit. Okay, explain natin yung mamaya. Susulat ko lang muna ngayon. So the Thevenin equivalent voltage is V. Okay, for emphasis, palitan natin ng kulay. Ibang maganda pang emphasize. Yan. Is the open circuit, which means no load voltage, okay, between two specified output terminals in a circuit. Okay? So, yun yung definition. Teka, i-move ko lang ito konti. Okay, and then, yung Thevenin equivalent resistance. Resistance is the total resistance appearing before or between, sorry, between two specified output terminals in a circuit. Okay. With all sources replaced by their internal resistances, which for an ideal voltage source is 0. Okay? So itong definitions na to, okay, for the Thevenin equivalent voltage and yung Thevenin equivalent resistance tells us how to solve for the how to solve them. Okay. Of course, yung Thevenin equivalent voltage, we call that VTH, and yung Thevenin equivalent resistance is RTX. Okay. So ito yung tatandaan ninyo. To solve for the Thevenin equivalent voltage, kailangan i-open nyo yung source. And to solve for the Thevenin equivalent resistance, kailangan i-close nyo yung source or you replace the source or sources with their internal resistances. At kung wala siyang internal resistance, then just replace it with 0. Okay. So pag sinabing 0, you tawag dito, you short it. Okay? So makikita natin yun dito. So again, ulitin ko lang, pag VTH, you open, and then dito, isi-short ninyo. You short it with the internal resistance, pero kung walang internal resistance, you just short it with the wire. Okay, so tignan natin itong circuit na to ngayon. Okay, and i-apply natin yung definition. Okay. Okay, so how do we solve for the Thevenin equivalent voltage? So we have this circuit. At yung circuit na to is composed of a voltage source, a DC voltage source na V sub S. Meron tayong resistance R1, okay, resistance R2, okay, and meron ding resistance na R3. Okay, and then meron kang, ang output is taken across points A and B. Okay. So, anong nangyayari dito? Or paano natin kukunin yung Thevenin equivalent voltage? So sabi natin, i-open natin yung, di ba? Thevenin equivalent voltage is the open circuit voltage between two specified output terminals, okay, in a circuit. Okay, so in other words, ano yung nakikitang voltage dito sa points A and B na to? So, if you take a look at the circuit, okay, and analyze it, makikita nyo that na merong voltage divider circuit. Okay. Ito yung voltage source, yung V sub S. Ito yung isang resistor na R1, and then yung isang resistor na R2. So itong tatlo na to, it constitutes your voltage divider circuit. Okay. So, alam natin kung paano i-treat yung voltage divider circuit, di ba? So, yung output is just R2 divided by R1 plus R2 times V sub S. Okay, what about itong R3 na ito? Okay. Since itong terminal A and B ay open yung terminals A and B, okay, ano yung current na dumadaan sa R3? Okay? So, walang current na dumadaan sa R3 kasi open itong circuit na ito eh. Hindi siya closed circuit, so walang current na dumadaan dyan. Okay. At dahil walang current na dumadaan sa R3, yung voltage across R3 is 0. So, in other words, walang effect yung R3 when we're trying to solve for the Thevenin equivalent voltage. So, ang Thevenin equivalent voltage is just the output across R2. Okay. Which we know that we can derive from using yung voltage divider na circuit. So yung VTH ngayon is equal to VAB and it's also equal to VR2. Okay, kasi alam natin na walang effect yung R3. And that means na and since yung VR2 is nothing but yung output ng voltage divider circuit, then yung Thevenin voltage is just yung voltage divider output sa R2. Okay, so that's how we solve for, or this is just one example that shows how to solve for VTH. What about RTH? So ang sabi rito is you replace all sources with their internal resistance. Okay. In this case, walang binigay na internal resistance for V sub S. So that means that we are going to replace yung V sub S with a short. So ito. Yan. So V sub S is replaced by a short. Then we take a look at kung ano yung equivalent na resistance at this terminal. Okay, remember na to solve for the Thevenin voltage, kailangan merong specified output terminals. Okay, merong specified output terminals. Okay. So merong specified output terminals. Okay. Okay. So, ano ngayon ito yung ating specified output terminals, A and B. Ano ngayon yung Thevenin resistance dyan? Well, since this is shorted, okay, ibig sabihin yung R1 at saka yung R2 ay parallel sa isa't isa. Okay, so we can redraw this, okay, as this. Okay, so R1, R2, right? And then we have R3, and then yun yung output. Okay, so R3. So, ang equivalent nito, okay, is R1, R2, R1 parallel to R2. Okay, yun yung nakikita niyo dyan. Okay, naintindihan niyo naman kung ano ibig sabihin niya, no? That's just 1 over R1 plus 1 over R2. Okay, inverse. Okay, so pinaliwanag ko na rin yan sa last meeting. And then, ang mangyayari ngayon is that you'll have this equivalent resistance, which is parallel ng R1 tsaka R2, in series with R3. Okay, so kaya you add R1, yung parallel equivalent ng R1 tsaka R2 with 2 R3. Okay, so R3 plus yung parallel equivalent ng R1 tsaka R2. And that's your Thevenin resistance. So now we have converted itong circuit na ito into its Thevenin equivalent circuit, na kung saan yung RTH is R3 plus R1 parallel sa R2, at yung VTH is just R2 over R1 plus R2 times V sub S. Okay. Any questions? Clarifications? Okay, sige. Kung walang questions or clarification, let's continue. Okay, so again, i-emphasize ko na kailangan yung piliin kung ano yung kung ano yung output terminals. Okay? And the Thevenin equivalent circuit will depend on which two terminals you are looking at. Okay? So kailangan yung ma-specify yun. So tignan natin ngayon dito sa ano na to, sa mga examples na ito. Okay, so if you're looking at A and B, kung yan yung specified terminals nyo, A and B, iba yung output niyan, iba yung Thevenin resistance niyan, okay, and yung Thevenin voltage, iba yung Thevenin equivalent circuit, okay, compared to when you're looking at B and C. Okay, so makikita natin yan dito sa example. So let's say na we're looking at points A and B. Okay, so yung ating terminals at gustong tignan ay A and B. Okay, A and B. Okay, so alam na natin na yung VTH dito, okay, is, okay, again, this is a voltage divider circuit. Ito yung ating, dito tayo nagtitake ang output sa R2 at saka sa R3. So yung ating Thevenin voltage dito is just R2 plus R3 divided by R1 plus R2 plus R3 times V sub S. Okay, and to get the Thevenin resistance, i-short natin itong V sub S. Okay, kaya siya na-short dyan. And then tignan natin yan yung equivalent na resistance. So this is in series, so R2 plus R3 yan. And yung result niyan is parallel to R1. So R1 parallel to R2 plus R3. So yan yung ating Thevenin resistance. So yung equivalent circuit is this, na kung saan ito ay R1 parallel to R1, R2 plus R3. Okay, so equal to sa R1 plus, R1 parallel to R2 plus R3. At ito naman ay equal sa R2 plus R3 over R1 plus R2 plus R3 times V sub S. Now, if we're taking a look at the output BC, so gumamit tayo ng ibang kulay. Orange. So BC, oops, hindi gano'ng nade-differentiate. Blue. So BC, if we're looking at BC, makikita natin na yung Thevenin voltage, iba na. Kasi nangyari is, we're just looking at R3. So it's just R3 divided by R1 plus R2 plus R3 times V sub S, yung source. And then yung equivalent na resistance, mag-iiba rin. Kasi now we're looking at R3 lang. Oops. We're looking at R3 lang. So, which means na R3 okay, will become, and if we short this, R3 will then be parallel to the sum of R1 and R2. So yung equivalent na resistance dito is R3 parallel to R1 plus R2. So dito, yung RTH is R3, okay, plus R3 parallel to R1 plus R2. Tapos ito naman ay R3 over R1 plus R2 plus R3 times V sub S. Okay? So this demonstrates na pag iba or nagde-depend yung Thevenin circuit, equivalent Thevenin circuit, okay, sa kung saan dalawang terminals kayo tumitingin. Okay? Okay, when you do or when you have performed or when you have converted ang isang circuit into its Thevenin equivalent circuit, then you say na you have Thevenized, okay, yung circuit na yan. Okay, so it's just a cool term para ma-shorten natin yung para hindi natin kailangang ulit-ulitin na sabihin na convert a circuit to its Thevenin equivalent circuit. You Thevenize the circuit. Okay. Okay, questions? Okay. Sige. Wait lang. I-ready ko lang ng konti yung okay, so mag-discuss tayo ng examples mamaya-mayang konti, okay, para mas malinaw pa sa inyo kung paano ginagamit yung mga circuits na ito. Okay? Okay, so next concept is called the maximum power transfer theorem. Okay, so it turns out that there is an ideal, ideal circuit, okay, such that the power transferred from one circuit to another is maximized. Okay, and to figure out kung ano yung maximum power na pwedeng i-transfer, okay, tawag dito, you use the maximum power transfer theorem. Okay, so ito medyo simple lang yung concept na to. So kasi for a given source voltage, maximum power is transferred from a source to a load when the load, for emphasis, load resistance is equal to the internal source resistance. Okay, when the load resistance is equal to the internal source resistance. Okay, so it's a very simple concept. Okay, but it's a little bit hard to implement. Okay, first of all, bakit mo gusto ng maximum power? Of course, gusto mo kasi na, di ba, na efficient yung pag-transfer ng energy. So when you charge your mobile devices, for example, okay, if you use a charger that is not designed for your mobile device, then that charger may overheat. Yung mobile device nyo ay pwede mag-overheat because the power transfer is not optimized. Okay? Paano natin alam na hindi optimized yung power transfer? Kasi iba yung resistance, iba yung load resistance kumpara dun sa internal source resistance. Okay, which means na some of the power, okay, is not delivered properly dun sa load. Okay? And yung power na yon na nade-deliver sa load is then is then converted to heat. Okay, yung hindi nagagamit na power is then converted to heat, and that's why your device heats up. Okay? So it's important that you use, okay, yung charger that is really designed for your mobile device, or at least you know yung specifications ng charger ninyo, okay, para pwede kayong gumamit ng ibang charger with the same specifications. Okay? So yun yung advantage ng maximum power transfer theorem. But ito yung implication yan. Okay, when designing, okay, a simple charger, for example. First of all, you have to know yung load. And again, you will know the load by simply measuring, di ba? Kung meron kayong mobile device, you measure yung resistance dito sa charging port. Okay, that's the load resistance. Tapos, yung charger nyo, i-design nyo ngayon yung charging circuit ninyo. Okay? To design yung charging circuit, you actually use the Thevenin circuit. Okay, so you have this Thevenin circuit. So for example, kung itong load nyo is 75 ohms, okay, you want this one to also be 75 ohms. You want the Thevenin resistance to be 75 ohms. And you want the Thevenin voltage to be 10 volts. Now, when you design your charging circuit, of course, you're going to use a voltage divider. Okay, so gagamit kayo ng voltage divider ngayon. Okay? Now, when designing the voltage divider, you need to figure out kung ano yung R1, R2, tsaka R3. Okay? And hindi ka pwedeng basta-basta pumili lang ng R1, R2, tsaka R3 ng tawag dito. Kasi it has to be equal to, dapat yung Thevenin resistance niya has to be equal to 75 ohms. Okay? So, furthermore, syempre yung charger nyo, nilalagay niyo yan sa di ba? Nilalagay niyo yan sinasaksak niyo yan sa 220 volt na source. And it's an AC source. So, kailangan mo pa siyang i-rectify para maging DC. Okay? And then, yung DC circuit niyo, dapat yung output sa DC circuit niyo, okay, is V sub S. And that also has to be Thevenized, okay, para yung output ng charger is 10 volts. Okay, so there's really a lot going on, okay, when designing these types of circuits. Okay, so how do you or ano pang pwede niyong gawin para lang para ma-optimize yung So what you do is to, of course, you want to provide the current. Okay? Kasi current naman is, di ba, yun yung dun na to transfer yung energy, di ba? So you want to have a current that's equal to V sub S over R sub S plus RL. Okay. Okay, so nakuha yan. Ito lang yan, yung circuit lang na ito. So yung current through this loop is, di ba, 10 volts minus current times RS, okay, minus current times RL is equal to 0. Okay, and when you isolate yung current na parameter, current na term, you get this equation. Okay, which means na yung power na transfer mo dun sa, or power na transfer between the load, okay, and the source, okay, is equal to I squared R, I squared RL, okay, where I is given by this equation. Okay. Okay. Okay, I think part ng exercise natin yung ano yung teka, let me just check. Okay, hindi pala siya part ng exercise. Okay. Anyway, so yun, yan yung basically yan yung maximum power transfer theorem. So you want to maximize yung power transfer between the load, between the source and the load. And to do that, dapat ideally yung source resistance has to be equal to the load resistance. Okay. Sige. Sige, there's still a bit of time. Dali. So let's just show kung anong nangyayari pag hindi pag hindi ideal yung circuit. Okay, so let's consider this example. So let's say na yung load natin, okay, ay or zero yung load. Ang unang case is that when the load is zero. So shorted yung load. So yung current ngayon dito is V sub S over R sub S plus RL, di ba? Given by this equation. If sa circuit ang V sub S natin is 10 volts, RS is 75. So 10 volts divided by 75 ohms. So that's equal to 133 milliamperes. Okay. And yung power is I squared R. So that's equal to 133 milliamperes squared times 0. Then yung power transferred is 0 watts. Okay, which makes sense kasi wala ka namang pinagtatransferan ng ano, di ba? Wala ka namang pinagtatransferan ng ang tawag dito, ng power dahil zero resistance siya. When we say zero resistance, it means na yung load is shorted. Okay? And when that load is shorted, okay? So, okay, yung load na to is shorted. Yan. Shorted yung load na yan. Okay, then anong tawag dito? Then yung power output or wala kang tinatransfer or wala kang device na pinagtatransfer no output. Okay, which diba, makes sense naman kasi wala ka namang load in the first place. Okay. So next, taasin natin ng konti yung load resistance. Okay, so let's say na yung load resistance is 25. In this case, okay, we have 10 volts divided by 75 ohms plus 25 ohms. So that's 100 ohms, 10 volts divided by 100 ohms is 100 milliamperes. And yung power, okay, is 100 milliamperes squared times yung load, which is 25 ohms. Okay, and this is equal to 250 milliwatts. 250 milliwatts. Okay, so letter C, increase natin yung load ulit. Let's say 50 ohms. Okay, so in this case, yung current is 10 volts divided by 75 ohms plus 50 ohms. Equal ngayon to sa 80 milliamperes. And yung power dito ay 80 milliamperes squared times 50 ohms. So equal to some 320 milliwatts. Then letter D. Okay, so letter D, RL is 75 ohms. So ngayon equal na yung load resistance with the source resistance. So yung current is 10 volts divided by 75 ohms plus 75 ohms. Equal ngayon to sa 66.7 milliampere. And yung power is 66.7 milliampere squared times 75 ohms. So this is equal to 334 milliwatts. And if you increase yung load resistance further, so let's say 100 ohms, yung current is 10 volts divided by 75 ohms plus 100 ohms. And this is equal to 57.1 milliamperes. So the power in this case is 57.1 milliamperes squared times 100 ohms at equal to sa 326 milliwatts. Okay. So dito makikita niyo na as you increase yung load resistance going to 75 ohms, okay, nag-increase din yung power. And then if you increase it further beyond 75 ohms, nag-decrease na yung power din. So you have this maximum power when the load resistance is equal to the source resistance. Okay? Okay. Now, it's not really linear as you see here, or actually, hindi naman siya obviously linear, di ba? Okay, when you graph it, it looks like this. Okay, so if you graph the power as a function of load resistance, then you get this blue line curve, and you can see clearly that it's maximum, okay, here at 75 ohms na load resistance. Okay. Any questions? Okay. Okay pa kayo? Okay, sige. Ayos. May mga iba na may energy pa. Kaya pang mag-react. Okay. So next concept is called, okay, the superposition, tawag dito, theorem. Okay. So, ano ang superposition theorem? So, isang sinasabi dito is that the current in any given branch, okay, the current in any given branch of a multiple source linear circuit can be found by determining the currents in that particular branch produced by each source acting alone, okay, with all other sources replaced by in their internal resistance. So the total current is the algebraic sum of the individual source currents in that branch. So anong ibig sabihin nun or anong sinasabi nun? Okay, sige, sulat muna natin. Okay, para nasa notes. Okay, so current in any given branch of a multiple source linear circuit can be found by determining the currents in that particular branch produced by each source. Acting alone. With all other sources replaced by their internal resistance. Okay, so anong ibig sabihin yan? So, first of all, tignan nyo muna kung meron kayong multiple sources. Okay, so of a multiple source, okay, linear na circuit. Okay, paano nyo alam na linear na circuit? Pag puro resistance lang yan, puro resistors lang makikita nyo dyan, it's linear. Okay, kasi the resistor behaves linearly, di ba? Voltage is equal to I times R. Pero pag may nakita kayong capacitance or inductors, capacitors or inductors, ano na sila? Non-linear na yung behavior nila. Okay, and yun yung magiging lesson natin sa susunod na meeting. Okay, so well, it's linear din sometimes, but in general, it's non-linear. Okay. Anyway, so you can determine yung currents sa particular na branch na yan, okay, by first setting one of the sources, okay, to its equivalent internal resistance. Tapos alamin mo yung current as a result of sorting or setting yung voltage source na isa to its internal resistance. Then, ang gawin mo next is i-short mo naman or i-replace mo by its internal resistance yung pangalawang voltage source. Alamin mo yung current as a result. Tapos yung total current, you can get the total current by adding yung dalawang currents na yun. Okay. So that's why this is called a superposition. So you can get the total current by simply removing or replacing one of the voltage sources with a short or its internal resistance at a time. Okay. So siguro magiging obvious to pag ginawa natin to example na ito. So tignan natin itong problem na ito. So pinapahanap dito is I2. Find I2. Here it is. Okay. Yan yung problem pag hindi tayo face-to-face, ano? Walang kwenta yung mga jokes ko. Hindi ko nakikita ang mga reaction ninyo. Okay, so find I2. So, para makita natin, so first, dalawa yung voltage sources. Okay, VS1 at saka VS2. Para makita natin yung I2, i-replace muna natin yung isa, let's say VS1, with its internal resistance or short. Solve for I2. Okay, solve for the current at R2. Then, i-replace natin yung VS2 with a short or its internal resistance. Then, solve for the current at R2. So, yung total current ngayon will be the sum of those two currents. Okay? Yun yung superposition theorem, basically. Siguro isipin nyo, bakit hindi ito tinuro sa Physics 102 nung pinapasolve kami ng mga problems? Well, hindi ko alam. Well, kasi ang focus dun is on the fundamentals. And dito, sa 173, slightly a bit advanced na kayo sa concept sa 102. So, ina-apply na natin actually yung concepts dito. Okay? So, ang importante kasi sa 102 is how you use yung Kirchhoff's voltage rule tsaka Kirchhoff's current rule. So, yun yung emphasis nun. Ngayon, ano na kayo doon? Nalagpasan nyo na yun and yun nga, natutunan nyo na siya. So now we're doing these advanced concepts. So ang gawin natin is i-replace muna natin yung VS2 with a short. Okay, so walang internal resistance yung ano yung VS2. So we're just going to replace it with the short. Okay, so dito sa B, nireplace na natin yung VS2 with the short. Okay? So alamin nga natin ngayon ano yung current dito sa I2. Okay, so para malaman yung current sa I2, remember na you have to choose a direction. Okay. So okay. So paano natin makukuha yan? So first kailangan natin i-simplify muna yung R3 at saka yung R2, right? So from this circuit, yung R2 at saka R3 ay parallel sa isa't isa. Then i-simplify pa natin yung further yung circuit at makita natin from the circuit na yung parallel equivalent ng R2 tsaka ng R3 is in series with R1. So yung effective na circuit is VS1, okay? Tapos meron kang equivalent na resistance na R1 plus parallel ng R2 tsaka R3. Okay, so yun yung makikita niyo. R1 plus parallel ng R2 tsaka R3. So yung total current ngayon dun sa circuit na yon is VS1 divided by yung parallel equivalent ng yung equivalent resistance ng tatlo. Okay, which is this one. Okay? Okay. So again, ang gusto natin malaman is yung current through R2. Okay. So paano natin makukuha yung current through R2? Well, we use ngayon yung voltage divider natin, di ba? So essentially, gusto natin makuha yung output dito. Okay, yung output voltage dyan, okay, is okay, so iba yung approach niya. So, but yung approach ko is based on yung sa napag-aralan natin. So yung output voltage dyan sa R2 is, sorry, hindi R2, hindi lang yan R2. R2 parallel to R3. Okay, remember, parallel sila, so pareho yung output dyan. So based on this circuit, it's R2 parallel to R3 divided by R1 plus R2 parallel to R3 times VS1. Okay, so once you know yung voltage across dito, you divide it by R2. So if you divide everything by R2 here, i-divide nito by R2, then you get I2. In this case, nilabel niya to as S1. Okay, S1 kasi shorted yung source 2. Okay? Okay? Now, it's easy to show na pareho lang tong dalawa na to. Okay? Sige. Dahil sinabi kong easy, panindigan natin, di ba? So, ang total current, remember, is VS1 over RT S1. So, that's this one. Okay, yan yung total current. Okay, at ito, okay, is 1 over R2 plus 1 over R3. Ulitin natin. 1 over R2 plus 1 over R3 times yung total current na S1. Okay. Yan. Okay. And then divided by R2. Okay. So, syempre, i-multiply, ipapasok natin yan doon. So, we have 1 over 1 plus R2 over R3 times IT S1. Okay? Or 1 over R3 plus R2, R3 plus R2 over R3 times IT S1. And if you take the reciprocal of this, then you end up with that. Okay? So yan yung current through R2 pag sinort natin yung source 2. Okay, now let's do the second case. Pag sinort natin yung source 1. Okay, so pag sinort natin yung source 1, then isa-solve natin yung current through R2. Okay. So, ganun din yung approach natin, but this time, ang parallel is yung R1 tsaka yung R2. Then, in series siya with R3. So, yung equivalent na resistance dito is R3 plus R1 parallel R2. And yung total current is VS2 divided by total equivalent na resistance, okay, given by this. Okay, and then we use the voltage divider equation again. Okay, so ang voltage divider equation in this case ay V, so we're taking the voltage across R1 parallel R2. So that's R1 parallel R2 over R1 parallel R2 plus R3, and then ITS2. Okay, yan. Okay, and this is, hindi ITS2. VT, VS. VS. Ito yung ITS2. Okay. And again, ang gagawin lang natin is pag dinivide natin to by R2, we get I2 when there's only S2 as a source. So we divide this by R2. So we have a 1 over R1 plus 1 over R2, tapos ITS2 over R2. Okay, so we have 1 over R2 over R1 plus 1, ITS2. So 1 over R2 plus R1 over R1, ITS2. And then the next step is this equation here. Okay, so the total current ngayon, okay, according to the superposition theorem, is just the sum of these two individual currents. Okay, I2, yung total current through R2, okay, is just the sum of I2 S1 at saka I2 S2. Okay, and of course, important na yung direction na pinili natin, okay, is the same, okay, for both of them. Otherwise, ma-mess up yung mga signs ng currents. Okay. Okay, so walang paraan para i-simplify yung yung equation na yan. So yung final answer nyo can just simply be this or this if this was tawag dito, if this was an exam or an exercise. Okay, questions? Any questions? Wala. Okay. So now, ang gagawin na natin is we're now going to solve some more problems. Okay, some more examples. So now consider natin itong unang example na ito. Okay, determine the current drain on the battery with no load on the output terminals. Okay, with a 10 kilo ohm load, what is the current from the battery? Okay, so we have itong dalawa tong tawag dito. Dalawa yung questions dito. First, when there's no load, and yung second question when there's a 10 kilo ohm na load. Okay. So consider muna natin yung case case 1, when there's no load resistance. So, ano yung current drain on the battery? So, in other words, ano lang yung current na tawag dito na dumadaan sa battery o na pinaprovide ng battery. Okay. So, ang output dito is across A and B. So, we want to find out the output between A and B. And by this time, medyo familiar na kayo sa voltage divider na circuit. And hopefully, naintindihan nyo na rin kung paano isolve kung paano alamin yung output sa isang voltage divider circuit. So if you recognize that this is a voltage divider circuit, you're looking for the output across terminals A and B. And in this case, yung output niyan is R2 plus R3 over R1 plus R2 plus R3 times 22 volts. So that's equal to 5.6 kilo ohms plus 2.7 kilo ohms plus 10 kilo ohms plus 5.6 kilo ohms plus 2.7 kilo ohms times 22 volts. Okay, so yung output voltage dito or yung voltage across AB is then equal to 9.98 volts. So 9.98 volts when there is no load. Okay. Mention ko lang na one of the common mistakes na nagagawa ng mga estudyante when solving problems, even during exams, is yung mga prefixes. Okay? So, pansin nyo na yung mga resistance dito ay may prefix na kilo. Okay? In this case, yung numerator has a prefix of kilo and yung denominator has a prefix of kilo. Okay, so ang mangyayari lang dun sa mga prefixes na yun is magka-cancel lang yung 10 to the 3 in other words. But in some cases, halimbawa pinapasolve sa inyo 22 volts divided by 5.6 kilo ohms. Minsan nakakalimutan ng estudyante na meron kang prefix na kilo. So ang nagiging sagot niya is in volts but not in millivolts as it should be. Okay, so yun yung pag-ingatan nyo. Tignan nyo mabuti kung ano yung prefixes na present para makuha niyo yung tamang order nung order of magnitude nung answer na hinahanap, na pinapahanap. Okay? So now let's consider yung case 2 na kung saan yung load resistance ay 10 kilo ohms. So saan nakalagay yung load resistance? Well, yung load resistance ay nakalagay dito. Okay, so nandiyan yung RL na 10 kilo ohms. So in that case, yung output voltage natin ngayon, okay, so across terminals A and B, yung R2 at saka yung R3 na in series ay parallel sa RL. Right? So ang output voltage natin ngayon is R1 plus R2 parallel to RL divided by R2 tsaka R3 pala to. R2 and R3. So divided by R1 plus R2 plus R3 parallel sa RL. Okay. So this is okay, so this is R2 is 5.6 kilo ohms. Okay. Siyempre gusto nating mas simplify ito para mas may nakalimutan ako dito. Anong nakalimutan ko? Yung 22 volts. So gusto natin mas madaling gamitin sa calculator, ayaw natin diretso na, di ba? I-gamitin lang yung equation na to ng basta-basta. Gusto natin na efficient tayo sa paggamit ng calculator. So we can write this as 1 over R1 over R2 plus R3 parallel sa RL plus 1 times 22 volts. Or basically, it's just 1 over R1 over 1 over R2 plus R3, sorry, R2 plus R3 plus 1 over Rn. It doesn't look nice, okay, pero yan yung efficient. Is efficient way para i-plug in sa calculator. Of course, yung isang efficient is just solve for R2, R3 parallel to RL. Okay, solve nyo muna yan and then saka nyo i-plug in dito sa equation yan. So when you do that, you get an output voltage which is 6.86 volts. Okay. Well, analyze natin, compare natin yung results. So when there's no load resistance, you get an output of 9.98 volts. But when there's a load resistance that's about 10 kilo ohms, okay, then tawag dito, then you get an output of 6.86 volts. So ang tawag dito sa effect na to, okay, is voltage loading. Okay? And the reason this happens is because yung load resistance, okay, has a value, okay, that is near yung sum nila. 5.6 plus 2.7 is 9.5, right? So magkalapit yung values nila, di ba? Magkalapit yung values nila. Sorry, 8.5 kilo ohms. So, and if you recall sa last meeting, para wala tayong maramdaman na voltage loading, dapat yung load resistance must be at least 10 times higher than yung resistance dito sa line na yan, sa branch na yan. Okay? So yun yung tawag dito. Yun yung reason kung bakit meron tayong voltage loading. Okay? Kasi itong load resistance is in the same order as the sum of these two resistances. Okay? Okay, so next. So we have this bridge network. To what value, okay, must RV be set in order to balance the bridge? Okay. So alam niyo naman kung ano ito, no? This is a schematic symbol for a tawag dito, a variable resistor, right? Okay. So pwede mong i-tweak yung resistance niya by turning the knob. Okay. And yun yung kailangan yung gawin dito. You tweak it such that yung output sa bridge is 0, okay, to balance the bridge. Okay, so for a bridge to be balanced, okay, VAB must be equal to 0, which means na R1 over RV ay equal sa R2 over R3. So RV ngayon is equal to R1 times R3 over R2. Okay, so ang R1 is 390 ohms. Okay, tapos ang R3 is 560 ohms divided by R2, which is 1 kilo. So ang RV is now equal to 218 ohms. Okay, so you turn the knob and set the resistance of that resistor to 218 ohms. And that will balance the bridge. Okay. Next. So determine the output voltage of the unbalanced bridge, okay, for a temperature of 65 degrees Celsius. Okay. The thermistor has a nominal resistance of 1 kilo ohm at 25 degrees and a positive temperature coefficient. Okay, assume that its resistance changes 5 ohms for each degree change in temperature. Okay, so first of all, ang unang given is, well, ang pinapahanap, okay, so find VAB, well, at a temperature of 65 degrees Celsius. Okay, so ang given dito is at 25 degrees Celsius, okay, yung thermistor has a resistance of 1 kilo ohm. Okay, and the bridge is balanced. Okay, so VAB is equal to 0 in that case. Okay, makikita naman natin kung balance, di ba? Hindi given, okay, hindi given sa problem, hindi given dito. Okay. Pero alam natin na balanced. Paano natin alam na balanced? Kasi 1 kilo ohm to, 1 kilo ohm to, 1 kilo ohm to. And to balance the bridge, dapat 1 kilo ohm din yung R1, right? So at 25 degrees Celsius, ang resistance ng thermistor is 1 kilo ohm, which means that the whole circuit is balanced. Okay. Okay, so ang coefficient is 5 ohms, 5 ohms per degree Celsius change. Okay, and this is positive. Okay, so in other words, ito yung ating increase, okay, per degrees Celsius. So we're looking at a temperature change of 65 degrees Celsius and 25 degrees Celsius. So ang delta T natin is 65 degrees Celsius minus 25 degrees Celsius. That's 40 degrees Celsius. Ano yung equivalent na resistance change? Okay, so again, for every degree Celsius, nag-i-increase yung resistance by 5 ohms. And alam natin na nag-i-increase kasi positive yung temperature coefficient. So, if yung increase is 5 ohms per degree Celsius at yung change is 40 degrees Celsius, then we have a resistance change of 200 ohms. So, itong R1 ngayon, from 1 kilo ohm, naging 1.2 kilo ohm, right? So, R1, okay, at 65 degrees Celsius is 1.2 kilo ohms. Okay, at pag 1.2 kilo ohm na yung yung resistor, yung thermistor, then what do we get? Okay, so now we use yung knowledge natin about tawag dito, about Wheatstone bridge. First, we solve for VA. Okay. VA is 1 kilo ohm. Okay, remember this is just one voltage divider. Diba? Divide by 1 kilo ohm plus 1.2 kilo ohms times 9 volts. This gives us 4.09 volts. Then we solve for VB. Okay, again, this is another voltage divider circuit. So that's 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm times 9 volts. So this is 4.5 volts. If we're looking at VAB, okay, pag hinahanap natin VAB, in other words, VA minus VB, then we have 4.09 volts minus 4.5 volts equal to negative 0.41 volts. But if we're looking at VBA or VB minus VA, then of course it's just 0.41 volts. Okay, so hindi naman sinabi dito kung ano talaga kung saan talaga kukunin yung output at ano yung reference. So either of these answers are the same as long as you indicate kung paano nyo mineasure. Okay. So, in this case, ang ginamit kong reference, sa unang case, ang ginamit kong reference is point B. And then sa second case, ang ginamit kong reference ay point A. Okay? So, you have to indicate that pag nagsisolve kayo ng circuit. Okay? So, para lang, di ba, para lang kayo nagme-measure. So, saan nyo ilalagay yung itim na probe? Di ba? Pag nilagay nyo sa point B, yung itim na probe, then you get negative 0.41 volts. Pero pag binaliktad nyo at nilagay nyo sa point A yung negative na probe, then you get positive 0.41 volts. Okay? Okay? Sige. Any questions? Okay, so I think that will be it for today. Okay, and as usual, ilalagay ko ulit dun sa ano natin sa notes, and I'll see you next week in class kung wala na kayong question. Okay, thank you for coming.